Okay, this is the first in a series of videos on the SQL query language. We'll be doing a few example questions using the football database that we talked about when we explored the two database systems, Postgres and SQLite. We're going to use Postgres for all of these examples. So, first thing that you need to think about when you're dealing with SQL is you're going to get information requests. The information requests are going to come in generally a vague format, something related to the data in your database. Well, hopefully. Of course, if they're not related to the data in your database, you can tell the requestor that you can't answer them. But if they are related, you've then got to consider whereabouts are the particular data items that are being requested located in your tables, and how can I extract just the relevant information from those tables. So anyway, we'll be looking at some example questions. You can see the first question down the bottom of the screen. First thing to do, of course, though, is to get into the PSQL command interpreter and start looking around. If you remember, the database has tables about goals, matches, players and teams, and a relationship, an end-to-end relationship about which teams are involved in which matches. There are other relationships in the system, but they're all one-to-N relationships, so they're handled as attributes within tables. Right, but we'll start out just considering individual tables. Okay, so the first request is, what teams are there? Well, the simplest way to answer that question is to simply say select all of the information from the team table, and that will give you a list of teams. Now, it contains the team ID. Maybe that information's not relevant, and maybe you don't want the column heading to be the same as the attribute name. You'd rather it say team and give you a list of teams. So in terms of SQL, a way that you could do that is to say, I want to select the country attribute, but I want to rename that as team with a capital T. So we put it in double quotes, and we want that to come from the team table. And well, they seem to be in alphabetical order anyway, so we don't need to do any ordering. So this will change what the output looks like. So now you get a list of teams. The heading on the column is team. If I hadn't put the quotes, this is what would have happened. Very subtle difference, but you can see that that is no longer capitalized. If it was important that the teams be in alphabetical order, and it just so happens that they are inserted into the database in alphabetical order, but if they hadn't been, then you could insist on that, and that would give you the same list, of course, because they were in order already. Okay, so that's, I think we've exhausted everything we can do with that first query. Let's take a look at the next query. How many teams are there? All right, well, we can see from the answer up here that there are 10 teams, but can we get the SQL query just to give us that information? And it turns out there's an aggregate called count that allows you to say how many tuples are there in the team table. So count star will simply count all of the tuples in the table that you mentioned in the from clause. So it tells us that there are 10 teams. Now once again, we've got a table heading count. The table heading is derived from the name of the function. If you didn't like that, if you wanted it to say something like number of teams, then you could do that and get a different table heading. So count is very useful. You can count individual things, so I could have said something like count the countries, and it'd still be 10. If there'd been duplicates, then you can use count to work out the number of distinct attribute values, but we'll be looking at that later on. Okay, so let's take a look at the next query. How many players are there? Okay, well, you should be able to work out how to do that based on the query above. So select count from player. So given the information request, how many players are there? We needed to know where the player information stored in the player table. How do I work out how many tuples are in the player table? I use the count aggregate. So there's 120 players apparently, which is true because I generated this data basically generating 12 players per team. Once again, you could change the column heading if you really wanted to, but there's not much more to say about that query. Let's take a look at the next one. Okay, what is the age of the youngest player? Okay, well, clearly the information is going to come from the player table. We know that in the player table, if we happen to have forgotten what the player table looks like, we could always look it up using \D. So there's a birthday and a name. So the age of the youngest player. So we're really just interested in the age. Well, first thing, how do we find the age? Well, it turns out that Postgres has a built-in function called age, which if you apply it to a date, it will give you the age corresponding to that date, and it assumes that date that you give it is a birthday, the date of birth. Alright, so if we really wanted to, we could initially find out all of the ages in the database. And as I said, the way we use the age function is, and let's, rather than just getting ages, let's get names as well. Okay, so you can see the format that the age function gives you. Technically, that's a PostgreSQL interval value. So we've got all of these various players and their associated ages. Now, the actual question, what is the age of the youngest player? We need to work out both the age and we need to find a minimum. And there's an aggregate in SQL called min, which will tell you the minimum of a sequence of values. We can compute the age, and so we could phrase the answer to that query, find the minimum age based on the birthday This won't tell us who the player is, but it will tell us what the minimum age is. Okay, so the youngest player here is 31 years old. Now that's pretty old for a football player. I guess this shows a little bit the fact that I first built this database about 10 years ago, and I based the birthdays on something that would kind of look plausible for a football player around that time. So now they're all 10 years older than they were when I first created the database. Okay, so that's an interesting one. Get a list of all the ages, and then from that pick out the minimum age. Okay, let's take a look at the next query. So the previous example gave us the age of the youngest player. It didn't give us the name, and just to show you that it's not so straightforward to do that, I can't simply put select name min age. And the reason that's going to complain is that min is a single value that's generated by considering all of the players, and then you're asking for name, but name by default refers to all of the player names in the table. So there's a mismatch there, and that error message is trying to tell you something like that. All right, now the way to solve this problem in SQL is that the first thing you have to do is compute the age, and then, if you like, ask again, who is the player that has this particular age? So in fact, what you need to do is a nested SQL query. So in Postgres, you can actually drop into an editor to modify your query. So I'll do that. The editor happens to be Vim. If you don't know how to use Vim, then you can set a different editor. Select. So remember that what we're interested in is when the query is who is the youngest player, presumably you want to know their name. If you really wanted to, we could also print the age. But okay, so we want to select the name of the player who satisfies the requirement that he has an age which is the youngest age in the database. So this second query here gives us the youngest age, and what we need, and that's going to give us back a single value. So what we can actually do is introduce a where clause to test a condition. Now I've started with a relatively complicated condition, but hopefully it won't be too challenging. So where the age of the player is the same as the result of this query here. Oops. Okay, so this is the query that gives us back the minimum age that's stored in the database. We take that value and we compare it to the age of each player, and we'll select the player who has that particular age value. Or there may be more than one player if there just happen to be two players who have the same birthday. Okay, so Dave Smith is the youngest player in the database. We could, I guess, check that. By asking a query like this. So we're going to order by birthday, but we want the highest birthday to come first, because the highest birthday obviously means the youngest player. So we want them to be ordered in descending order on birthday. So if we were to ask this query, we'd see that Dave Smith was born 24th of December 85. The next player was 16th of December 85, and so on, and they're gradually getting older and older as the birthdays recede into the distance. A potentially simpler way to answer that query, I'll just go back and edit it, would have been to say where the birthday is equal to the maximum birthday in the system. So that obviously the person with the most recent birthday is the youngest player. So that's potentially a simpler way of answering that query. And I guess if I wanted to, I could show birthday for this particular player and the age. So let's see the result there. Okay, so Dave Smith, born on 24th of December 85, is 31 years, blah blah blah. Okay, hopefully that wasn't too tricky, but occasionally, particularly if you come across an information request that says something like find the largest something in the database, the first, it's easy enough to find the largest value, but then if they say which tuple has this largest value, you need to use a structure something like this, where you ask a query to find the largest or smallest value, and then you plug that into an outer query that that discovers the tuple that has that particular value, and then you can select whatever attribute you want from that tuple. Okay, next one. Which players are over 40, which players are under 30? Alright, that's probably easier than the one that we just looked at. So let's get the names and the birthdays of these players. And here what we're interested in is their age. Is greater than 40 years. And if you want to use a value like this in Postgres, you have to indicate that the string that you just typed in is of type interval. Now I'll go back and edit that in a minute. Hopefully the query will work and we can see all of the old players, and there are in fact quite a few of them, or 18 of them. Let's edit that query and I'll format it differently so it's a little bit more obvious. Generally I'll format my queries like this when I'm not typing them on a single line. So we've asked for the name and the birthday of all the players who satisfy this condition here, that their age is greater than 40 years, and you can't just type the string 40 years, it'll complain there's a type mismatch. So if you cast it to an interval value, so you say take 40 years, the string 40 years, and treat that as a value of type time interval, and then it's comparable against the age, which is of course a time interval as well. So I'll just, I will show you what happens if you just type 40 years without telling the system that it's an interval. Oh, it works anyway. Good. Wasn't expecting that. So sometimes the system will do automatic typecasting for you, and it will say, okay, I recognize that string as being a legitimate value of type interval. So we get the same 18 players. Okay, so let's take a look at the next query. What kind of ratings are given to goals? Okay, well, if we look at the goals table, which happens to be called goal, we can see that it's scored in a particular match, scored by a particular player, scored at a particular time in the game, and is given a rating. And the rating is just a text string. So we want to know what kind of ratings people have given. Now, one way we could do that is we could say select rating from goal, and that will give us a list of all the ratings, and we can see good, excellent, amazing, blah, blah, blah. We could continue scrolling through because there's quite a few goals, but a better way to answer that question, because you're only interested in the distinct value for ratings, and Postgres happens to have a mechanism for allowing you to extract just distinct values. So this will effectively run the previous query but eliminate all of the duplicates. So we'll only see amazing ones, we'll only see good ones, and we'll only see excellent ones, and whatever other values happen to be in the table. And it turns out that there are no other values in the table. So distinct is a very useful way of finding out what are the unique values from a particular attribute. We could try, what else could we try? I guess we could try something like when scored, but if you ask with an attribute where there aren't likely to be distinct values, and I should have checked the name of that attribute before trying time scored. Then not likely to get, since there are a lot of different times when the goal might be scored, you're likely to get pretty much the same value that you would get if you didn't put distinct, although there may be some duplicates. Let's just check that. Oh yeah, okay, so there were 73 distinct scoring times and 167 total goals. So there were some goals that were scored at the same time in different matches. Right, so we've worked out what kind of ratings are given to goals. What about the next question? How many of each kind of rating? Okay, so let's just back up to not distinct ratings, but select rating from goals, and let's add a condition that we order by the rating. Okay, so we can see a bunch of amazings come out, then a bunch of excellents, and then a group of goods. So what we're interested in doing basically is counting the size of each of those groups. So there's a group of amazings, a group of excellent, and a group of good. So the way to do that in SQL, there's a functionality called group by, which allows you to treat a collection of tuples that have a common value for an attribute as a group, and then you can ask questions that summarize the content of that group. So essentially it allows you to use aggregates on groups of tuples in the table. So in this case we could do that. Rather than order by rating, we want to group by rating, and you can think of group by rating as first of all doing that, and then what we're interested in doing is counting the size of each of those groups. So count star comes back into play. So select the unique ratings from the goal. So we're grouping by the rating, and then we're counting the size of each of those groups. So we can see there are 92 good goals, 37 amazing goals, and 38 excellent goals. So using group by is a very powerful tool, allowing you to group sets of tuples and then perform various aggregations on them. You need to be a little bit careful using group by. Whatever you group by here must also appear here, so that gives you, essentially tells you what are the groups, and you can have more than one attribute to define a group as well, and then you can apply whatever aggregation would make sense. So I can't think of another aggregation that would actually make sense in this context. Okay, so group by, very important, and group by has an auxiliary clause that you can use to answer queries like this. So we're only interested in talking about ratings that are applied more than 50 times. So what we need to be able to do here is effectively filter based on this attribute of the group. And the way to do that in SQL is there's another clause called having. So having essentially allows you to specify a condition that applies to the group. And in this case, the condition that we're interested in is that the count of tuples in the group has to be greater than 50. So the only rating that occurs more than 50 times is the good rating, as we can see from up here. Okay, so there's a brief introduction to SQL queries, and all of those queries involved just a single table. So hopefully that's given you a good start, and towards the end we were getting relatively powerful queries that allowed you to answer quite sophisticated questions. Okay, that's it for this video.